So one of the things that we did in chapter 8 was we looked at how to solve, come up with a non-linear equation that goes through points. So an equation of the form y equals ab to the x power. And one of the techniques that we discussed was using this method of substitution. It turns out this works for linear equations as well. But if you take a look at it, I've got 2 points here, and each one has an x, y value. This one has an x and a y value. And if I look at the x and y, I can take those values and plug them into this form y equals ab to the x power. So if I look at this value of 40, I can plug it in and I can get 40 equals and then a times b and then raised to the third power. So both of those equations are given here, right? This is the equation that I get from the first point, from the x is 3 and y is 40. And this equation is the one that I get from the second point when x is 8. You can see I've got to the 8th power, and y is 1280. So now that I've got that system of equations, the question is, how do I solve it? And I'm going to tell you, I've done a lot of different things. I've looked at what the book does. This is my personal favorite. You guys can use this or use something different, but this is what I like to see. So I'm going to take that first equation and I'm going to solve for a. So I'm going to rewrite this so that it's 40 divided by b to the third power equals a. So take a look at that. Concentrate. What I'm doing is I'm just dividing both sides by b to the third, right? That's all I'm doing. And I'm going to take this value, right, of a that I just found, 40 divided by b to the third, and I'm going to substitute that into the second equation. So instead of writing an a there, I'm going to write 40 over b to the third. So this equation becomes the following, right? This because of substitution, it becomes 1280 equals, and a is 40 divided by b to the third power, and I'm multiplying that by b to the 8th power, and I can write it over 1 if I want. Now, this is nice. We're super good at simplifying expressions that look like this. In fact, we do ones that are so much more complicated. This doesn't even take we don't even break a sweat here, right? So if I've got b to the 8th over b to the third, that's just b to the 5th power, right? I can simplify that all day. So this becomes 1280 equals 40 times b to the 5th power, right? B to the 8th divided by b to the third is b to the 5th. Now I'm going to take I'm going to divide both sides of that by 40. And if I take the 1280, and yes, I'm using a calculator off screen here. If I take 1280 and I divide it by the number 40, I do get 32, right? So I know that after I divide both sides by 40, I get the number 32. And look at it, 32 is b to the 5th power. Okay, so now I just need to figure out what b is, right? And what's so nice is because I think we understand how to take a power and raise it to a power. Just check out this strategy. I like this. Maybe you won't like this, but I like this. I'm going to raise both sides of this to the 1/5 power, right? I'm going to raise both sides to the 1/5 power. So if I have a quantity and I raise both of those quantities up to the same power, right, I should get the same result. And over on the right hand side, when I take b to the 5th and raise it to the 1/5 power, I get b to the 1st power, which is fabulous, right? That's what I want. I want to know what b is, and that is b to the 1st. On the other side, I have 32 to the 1/5 power, and I want to grab my calculator and evaluate that. So I'm going to take the number 32, and I'm going to raise it to the power of, and I'm going to actually grab the, whoops, not that. I'm going to actually grab the, I think it's alpha. There we go. There's this fraction tool. So I'm going to grab this and go to the 1/5 power. There's other ways you can do this. In fact, let me show you another way to enter it. So this is b to the 1/5 power, and I get the number 2. Yeah, 2 times 2 is 4, times 2 is 8, times 2, well, I'm doing that and I'm not writing down anything. Here, 2 times 2 is 4, 8, 16, 32. And you can see there's 1, 2, 3, 4, 5 factors of 2. So this ends up being just the number 2. B is the number 2. Another way you can enter that on your calculator is you could enter 32 and then raise that to the power and then use a I might be careful. I probably would use parentheses here. I could do to the 1/5 power. Let me try another one. 32 to the 1 divided by 5 power. I think that should be the same. Yeah, it's 2 also. So be aware of your calculator and some of the ways that it might interpret these expressions differently. But you can see all of these. 32 to the 1/5 power is 2. So b is 2. Now my problem is I know I'm being asked to write the equation of the line in this form. And the form is, if you recall, y equals ab to the x power. We've got a big chunk of this out of the way. We now know confidently that b is the number 2. Our question is, what's a? And that is not going to be a problem because of this, right? If you look at it, I've already got a alone there, so I can just bring my value of b in there and figure out what a is. So we know that b is the number 2, well, we think it is, and I think that a is the same thing as 40 divided by b to the 3rd power. So you can see I'm just cubing b. So this would look like 40 divided by 8. What? Are you kidding? So a is 40 divided by 8 is the number 5. So I think that we've got our solution, right? I believe that our equation is, because I know my 0th term and I know my multiplier is 2. I believe the equation is, and I'll zoom out and write this down here, y equals, let's see, yep, 5 times 2 to the x power. Now I'm going to verify that using our 2 known points, right? All I'm going to do is I'm going to plug x in to that equation on the right hand side and verify that I do get the target y's. And you're like, what are the target y's? Well, I put in 3, I should get 40. And if I put in x is 8, I should get 1280. So that's what I'm looking for there. So if I enter 5 times 2 raised to the x power, but instead of x, I'm going to put the number 3, you can see I get 40. Fabulous. And if I enter 5 times 2 to the 8th power, when I press enter, I get 1280, which is fabulous, right? So this is producing exactly the correct outputs with the given inputs here. So we're going to conclude this one. The equation of the exponential curve it's in the form y equals a to the x, and it goes through the 2 given points as y equals 5 times 2 to the x power. We arrived at that by using this technique of putting in our variables that we had, right? We had this variable x and this variable y, x and y. We plugged those in and then just solved for the parameters, solved a system of equation to find the parameters a and b. All right, let's go on to the next question.